Welcome back, guys. So in today's video, plan is we're going to get some low speed power running through this siren just to check that the motor's functioning okay, and that there's no rubbing between the rotors and the stators in either side there. And we're also going to get the rotor bolts on the sides there, either side, taken off, ready for the to start stripping it down. So there is one quick check we can do. It's by no means a comprehensive check of the windings insulation, but can give us a quick idea just to make sure we've got no dead shorts. So I've just got a multimeter set up there, and it's just set on the continuity setting. So if I short between the two leads there, you can see we get a 0 reading on the meter there. So we're just going to check between each of the windings and the windings down to earth. If we're all good, we should have a reading of 1. That at least let us know that there's no dead shorts on the initial wiring there. So got an earthing point just down there. So we go between that and each of these windings on the connections there. We've got a 1 on all them, so that's looking good. And then we can just go between each of the sets of windings as well, just to make sure there's no shorts between any of those either. And we're looking okay on those. Double check that last pair there. Yep. So what we'll do, we'll temporarily just hook a cable up onto it, and we'll run it through the inverter at the top there, just on low speed, just to make sure the motor's functioning okay. Okay, so we've got a temporary power supply hooked up into that now. That's going to run up through this cable here, up into the inverter. So with the inverter, it's just a device that allows you to convert 240 volt single phase into 415 volt three phase. So this is what we're going to use just to run it up and test it. So usually at maximum speed it will be displaying 50 Hertz. At the minute it's showing 3 Hertz. It's going to do a very slow run just for its first one. We just want to check the spin direction. So the rotors should be spinning away from the electrical box. As you can see, it has the solid front there, so that's what should be forcing the air out through the scoop. So if it does run the wrong way, it will have a bit less power to the sound there. And what we can do, we can swap over 2 of the phases that will make it run the right way. But I think I've got it wired up right, so we just select the cycle. So we just want an all clear signal. So if we just start that up now, should see the inverter powering up, and we've got the siren just spinning slowly. She's going in the right direction. So what I'll do is I'll just let that free fall while I shut the power to the inverter off, and we'll make sure it coasts down nicely. Don't appear to be hearing any rubbing there, so that's a good, always a good sign. So what we'll do, we'll ramp that up a little bit, maybe to about 8 Hertz for now. Just give her a bit more power run there, and then we'll see how that goes. Okay, so we've got the inverter set for 8 Hertz this time, so we should get a bit more speed and power out through it. We'll just give her a go on that. We've got a nice slow run down there, so I don't think we've got any issues with rubbing there, so that's quite good. So we'll get that disconnected for now, and the next job will be get those rotor bolts off, and then we can start the strip down on it. So we've got the siren up on its side, ready to have a look at removing these bolts holding the rotors on. On the castles, as you can see, it used a double bolt system there, kind of the second working as a lock nut, as opposed to the latest Seeker Max, which just had a bolt going through it there. So for these, the closest I found is one of these humongous 33mm sockets. I've also got my breaker bar and spanner down there. I've already put some penetrating oil down in there. That's just working its way down in there, because these nuts have probably been on there since it came out of the factory, probably back in the 70s or 80s, so they've been on there quite a few years. Obviously, as you try turning these to release them, the rotors are going to want to spin, so we need to stop that from happening. So I've got a couple of rubber chocks there and some soft pine wood, because what we're going to do, we're going to need to wedge these in here between the rotor and stator to stop that from spinning as we're trying to release the nuts. But because these rotors are aluminium cast, what we don't want to do is put too much pressure on and sort of bend or deflect the rotor vanes in any way there, or cause any damage to them. So although we're going to have to put quite a bit of force to get them nuts off, at the same time we've got to be careful that we don't cause any damage to the rotors. So I said on this one, obviously we didn't have too much issue with rubbing on. The main cause for the rubbing is actually down here where the steel motor flange meets the stator there. So the stator's cast aluminium as well, and the same as with the oxide powder we saw building up in the box here, that also sometimes builds up between this flange and the stator and actually pushes the stator out away from the motor. And what that does, that causes the stator to hit the back of the rotor and stops it from spinning freely. So a lot of the time that's where the issue is coming from. So the easiest way is to take the rotor stators off, clear all that oxide which is built up in between, which I'm sure, even though this one's not rubbing, there probably will be some there. And then the stators will sit more back in their normal position and that rubbing will stop. Unfortunately, I have seen before, people have obviously thought the rubbing issue is around the edges here and tried bending out the stators. Unfortunately, that will just destroy the siren. So the gap between the rotor and stator here has to be as small as possible in order to keep the air pressure up inside the siren, because as it's running, the air is sucked in through the ends here and blasted out through these holes. And the different amount of ports and stators are what give you the tones. So obviously we've got a 10 port, 12 port on this one, which is the usual sort of British setup. So what we'll do, we'll get these nuts off. Obviously, because they're locking nuts, what I have to do, we have to try and get the first one freed first. So when we put this on, we don't want it to cover both. We only want to try and release that top one, otherwise they'll be working together and just locking it up. So we'll get that top one off first, and then the base one, and then we can get the washer off inside, and then we'll be able to see the keyways on the motor shaft once that's off. So first job, we'll get this end off and then flip it over and get the other end bolts off as well. Okay, so after much persuasion, we've just managed to get one side to start freeing now, and they're actually coming off together rather than apart, but off is off, so that's always good. Let's get those ones out. There we go, so that's the first lock nut that's popped off there. And the main nut free there, so we've just got a split washer there and the main washer there. We can just see in there now, you can see the cutout square at the top there for the keyway. So that's actually on the motor shaft itself, so there's a cutout in there for that, and that's just so when the motor's spinning, it engages the rotor and stops it from slipping. So that's one side out, and then we'll carry on getting the other side, and then we'll have a go at pulling these rotors off. Okay, so we have managed to completely pull the 12 port rotor off there. Unfortunately, the bolts on the 10 port side are having none of it, so I'm going to have to set up a different day and get some heat on those to get those released. But luckily the 12 port, like I said, did pop off, so we can see the keyway, the motor key there, and you can just see where that's cut into the shaft there. We've also got a nice original paint colour on the inside there, so you can see the later grey. It was painted in situ, but you can see all the original colour on the inside there. So we've got the 12-port rotor off. You can just see where the keyway goes into it there, just so the motor shaft can engage the rotor, stop it slipping. And if we flip that over, we can actually see the holes that were drilled in the back of it there. So this was for balancing the rotors out, so to stop any vibration or jumping on the siren there. So again, we'll see something similar on the other side, but it's just a bit like when you balance the wheels of your car, I suppose. So so we're getting there. So once I've got them lower bolts off and the 10-port rotor off, there's just the 4 bolts to release there, which will separate the stator from the motor body there. So that'll be a next job as well. And then we can start getting some of these parts blasted and painted up then. Thanks for watching, guys.